Okay, so now we're going to talk about example 3 and 4 and why we have this thing called standard form. So if you remember, standard form is ax plus by is equal to c. And the reason we call it standard form is because a, b, and c need to be integers, which means that there is no fractions, no decimals, only whole numbers. They can neither be positive or negative, but they have to be integers. Okay, so if I look at example 3, writing an equation in standard form, write the following equation in standard form. Okay, so standard form, we have x and y on both sides with the constant on the other side of the equal sign. So if I look at y equals negative 7x minus 9, the constant is going to be the negative 9. That's our c. Okay, which means that I need to move this guy over here. Okay, so if I have y is equal to negative 7x minus 9, in order to move that negative 7 over, I add it to the other side. Now I can't add 7x to y. They're not like terms. So we just end up with 7x plus y is equal to negative 9. And that's your standard form. If I look at b here, you can pretty much figure out what the constant is. That would be the negative 5. That's our c. But this right here is not an integer. Okay, so I'm going to show you a little trick that maybe some of your math classes probably haven't taught you, is how to get rid of that fraction. So a fraction is just division. So in order to get rid of division, you do multiplication. So we really have, what's making this a fraction is this 4 in the denominator there. So to get rid of that, we are going to multiply everything by 4. And what we do on one side of the equal sign, we have to do on the other. So what happens is that whenever we distribute this, these 4's cancel out. And so we would have 4y is equal to 3x minus, and 5 times 4 is 20. Okay, so now I only have integers, which now it's pretty easy to go to standard form. This is my constant, so I need to move the 3x over here. So I'm going to subtract 3x. And so that would give me negative 3x plus 4y is equal to negative 20. And that's your standard form. Letter C here maybe looks a little tricky. You notice that we don't have constants. Well, we do have a constant, the 3.6, but it's not an integer. Okay, so we need to make all of these integers. Again, here's another trick that you probably have not learned. So one place after the decimal, that's called the tenths place. So in order to move that decimal over to make it a whole number, we need to multiply everything by 10. And what we do on one side, we do on the other. So whenever we multiply by 10, I would get 91x plus 36. Okay, multiplying by 10 just moves that decimal over. So now we just need to get it into standard form. So subtract 91x. I have negative 91x plus 10y is equal to 36. Okay, so even if you have a decimal or a fraction, it's really easy to get to integers if you know what you're doing. So now let's look at example 4, graphing an equation using the intercepts. So why the heck is standard form a thing? It is useful to find x and y intercepts. It is so easy to find x and y intercepts if it's in standard form. So what is an x and y intercept? So an x-intercept is where a line crosses the x-axis. So right there, that's your x-intercept. Your y-intercept is where it crosses the y-axis. Now, for any x-intercept ever, your y value is always going to be 0. Okay, because you're not going up or down at all. For your y-intercept, your x value is always going to be 0 because you're not moving left or right. And that's the key to finding these intercepts. So if you're looking for a y-intercept, then set y, or I'm sorry, if you're looking for an x-intercept, set y to 0. If you're looking for a y-intercept, then x must equal 0. So in our equation here, if I'm looking for an x-intercept, I'm going to substitute 0 in for y. So 5 times 0, that just goes away. And now we have this very simple equation to solve. Divide by 3, x equals 5. So that means that the coordinate of your x-intercept is 5, 0. The same thing works with the y-intercept. We're going to set x to 0. So now this 3 times 0, that goes away. We are left with 5y is equal to 15. Divide by 5. Y equals 3. So that means that your y-intercept is 0, 3. So if you come over here on your graph, let me draw a set of axes here. So your x-intercept was 5, 0. So 1, 2, 3, 4, 5. Talking right there. Y-intercept is 0, 3. Right there. And then you can just draw your line. Okay? So instead of having to do the whole rise over run and finding the y-intercept and, doing all that, it's really easy to whenever the equation is in standard form. So we're going to try it with the next one. So if I'm looking for my x-intercept, that means that y is 0. If I'm looking for a y-intercept, that means x is 0. So in my equation here, if I'm looking for my x-intercept, that means I have 2x minus 4 times 0 is equal to 8. 4 times 0 goes away. 2x is equal to 8. Divide by 2, x is equal to 4. So your coordinate is 4, 0. On the other hand, if you're looking for a y-intercept, set x to 0. That goes away. Negative 4y is equal to 8. Divide by negative 4. Y equals negative 2. So your y-intercept is 0, negative 2. So if you come over here to your graph, your x-intercept was 4, 0. Your y-intercept is 0, negative 2. And you can draw your line. There's not much more to it than that. So try the practice problems on the next page, and if you have questions, let me know.